The moon. It hangs in our night sky, a silent silver companion. For all of human history, we have looked up at its face. We see its craters, its mountains, its vast, dark plains we call seas. It seems unchanging, a perfect ancient sphere. But what if I told you that we, the inhabitants of the little blue dot nearby, decided to give the moon a tattoo? Not with ink, of course, but with fire and metal. We chose a specific day to mark our neighbor, to strike its surface with a piece of our own technology. This wasn't an act of aggression, it was an act of profound curiosity, a bold attempt to uncover one of the moon's deepest and most vital secrets, a secret that could change everything for future explorers. Imagine the universe as a grand library, and every celestial body is a book filled with stories. The moon is one of the oldest books on our cosmic shelf. Its pages are made of dust and rock, and they hold the history of our solar system written over billions of years. But some of its most precious secrets are locked away, hidden beneath the surface, in places where the sun never shines. For years we could only read the cover. Scientists, driven by that insatiable human need to know what's on the next page, devised a plan. A daring, explosive plan to force the moon to reveal a chapter it had kept hidden in permanent darkness for eons. The story begins with a mission. NASA, the American Space Agency, called it LCROSS. That stands for the Lunar Crater Observation and Sensing Satellite. The name sounds technical, but the idea behind it was beautifully simple, almost like a child's experiment on a cosmic scale. The plan was to throw something at the moon, and then watch what splashed out. We wanted to peek into the shadows, into the perpetually dark craters near the moon's poles. These are some of the coldest places in our entire solar system, places that haven't felt the warmth of direct sunlight in billions of years. What mysteries might be frozen in that eternal night? So, the stage was set for a cosmic collision. On October 9, 2009, humanity prepared to leave a small temporary scar on the lunar surface. It was a carefully aimed punch, designed not to harm, but to learn. We were about to create our own meteorite impact, a controlled event that would allow us to analyze the debris. This wasn't just about making a bang, it was about listening for the echo, sifting through the dust, and searching for the answer to a question that has captivated dreamers and engineers alike. Is there water on the moon? The answer was waiting for us, buried in the cold, dark dust. The plan required two key players. Think of it as a 1-2 punch delivered across 250,000 miles of empty space. The first player was the heavy hitter, the Centaur upper stage of the rocket that carried the mission into space. This was a big, empty fuel tank, weighing over 2 tons. It was our cosmic cannonball. Its only job was to fly straight and true into a designated crater near the moon's south pole. Its name was Cabeus Crater. This crater was chosen very carefully. It was deep, dark, and perpetually shadowed, making it a perfect spot to preserve anything that might evaporate in sunlight. The second player was the brains of the operation, the LCROSS spacecraft itself. This smaller, smarter probe was the observer. It had a very important and very brief job to do. After releasing the big Centaur rocket stage on its collision course, the LCROSS probe would follow right behind it. It was designed to fly directly through the plume of dust and debris that the Centaur's impact would kick up from the crater floor. It was a suicide mission for both parts of the spacecraft, but one with a noble purpose. The little probe would be our eyes and our nose, sniffing and tasting the ancient lunar soil for the first time. The journey was long and carefully choreographed. For months, the conjoined spacecraft looped around the Earth and Moon, adjusting its path, lining up the perfect shot. The scientists on Earth were like cosmic archers, making tiny corrections to aim their arrow at a target they couldn't directly see. It was a triumph of mathematics and engineering. Hitting a specific crater on the moon from Earth is an incredible feat of precision. It's like trying to throw a needle from one city and have it land perfectly inside a thimble in another city hundreds of miles away. Every calculation had to be perfect to ensure the impact happened exactly where and when it was supposed to. As the final moment approached, the two spacecraft separated. The Centaur rocket stage, now just a piece of space junk with a grand destiny, sailed silently toward its doom. It was traveling at a blistering speed of 5,600 miles per hour. Behind it, just 4 minutes behind, the LCROSS Shepard satellite watched its charge go in. Its cameras were on, its scientific instruments were ready to record. It would have just a few precious minutes to analyze the cloud of debris before it, too, would meet its end on the lunar surface, becoming a part of the very mystery it was sent to solve. The moment of impact was both dramatic and strangely silent. There is no air on the moon, so there was no sound, no thunderous boom to echo across the plains. There was only a brief flash of light, a burst of heat, and a cloud of material erupting from the darkness of Cabeus crater. The Centaur rocket stage struck the lunar floor with the force of 1.5 tons of TNT. It gouged out a new crater about 65 feet wide inside the old one. It was a powerful, precise strike that blasted tons of rock and dust high above the lunar surface, some of it reaching miles into the black, airless sky. This plume of debris was the whole point of the mission. It was a ghostly column of ancient material, thrown up into a place where sunlight could finally reach it after billions of years in the dark. For the first time, we could get a good look at the stuff hidden in these permanently shadowed regions. The El-Cross probe, flying just behind the impact, had a front row seat. Its instruments stared intently at this blossoming cloud. It measured the light, it analyzed the chemical composition, it looked for the telltale signatures of specific molecules that scientists were desperately hoping to find. The data streamed back to Earth in real time. In the control room at NASA, scientists held their breath. They were watching the final moments of their creation unfold on screens. The El-Cross probe flew bravely into the debris cloud, sampling the ancient dust. It saw the size, shape, and concentration of the particles kicked up by the impact. For 4 minutes, it was the busiest little probe in the solar system, gathering as much information as it possibly could. Then, its mission complete, it followed the Centaur into the crater, creating a second, smaller impact, and a second plume for telescopes on Earth and in orbit to observe. It was a spectacular, fleeting event. 2 man-made objects sent from Earth had scoured the moon to unlock its secrets. For telescopes on Earth, the plume was a faint and difficult thing to see, but for the instruments on the El-Cross probe and the Lunar Reconnaissance Orbiter flying high above, it was a treasure trove of information. The mission was over in a matter of minutes, but the data it collected would be analyzed for years to come. The moon had its new tattoo, and humanity was about to read what it said. So, what did we learn from this cosmic crash? The results were even better than scientists had hoped. As they sifted through the data sent back by the El-Cross probe in its final moments, they found what they were looking for. The instruments had detected the undeniable chemical signature of water. Not just a few stray molecules, but a significant amount. The plume contained water vapor and ice crystals. The permanently dark frozen floor of Cabeus crater was indeed a reservoir of frozen water. It was a stunning confirmation, a eureka moment for lunar science. The discovery was a game-changer. The mission found that the soil in this crater contained about 5.6% water ice by mass. That means if you took a ton of this lunar dirt, you could extract over 12 gallons of water from it. This wasn't just a scientific curiosity, it has profound implications for the future of space exploration. Water is heavy and expensive to launch from Earth. Finding a local source on the moon means future astronauts wouldn't have to bring it all with them. They could potentially mine this ice and use it for drinking, for growing plants, and even for creating breathable oxygen and rocket fuel. But water wasn't the only thing we found. The plume was a chemical cocktail of other interesting compounds that had been trapped in the ice. The probe detected hydrocarbons, ammonia, and even hints of silver and mercury. It was a snapshot of the types of materials that have been accumulating on the moon for billions of years, delivered by comets and asteroids. Each discovery adds another piece to the puzzle of how our moon, and indeed our entire solar system, formed and evolved. The dark craters are like cosmic time capsules preserving a record that has been erased from the more dynamic surface of the Earth. This deliberate act of cosmic graffiti has reshaped our understanding of the moon. It is no longer just a dry, desolate world. It is a place of hidden resources, a potential stepping stone for humanity's journey into the cosmos. The El-Cross mission invites us to dream bigger. If there is water, what else might we find? What other secrets are locked away in the lunar shadows? The moon looks the same as it always has, but now, when we look up, we know it holds the promise of a drink for a thirsty astronaut and fuel for a rocket bound for Mars. What will be the next mark we make on the cosmos in our endless quest for knowledge?